Hello, and welcome to notes number 5. This is on elimination method to solve a system. So far we've learned how to graph two lines to find their point of intersection, and we also learned about the substitution method that we can use to solve a system algebraically without graphing them. But sometimes, even with the substitution method, it might be difficult to do because you will end up with coefficients that are fractions or difficult decimals when you're trying to solve for a variable. So today we're going to take a look at a third method called the elimination method to help us solve a system. Now, before we get started today, there is a typo in our example. Today we're going to take a look at this example, 3y minus 2x equals 1, but it should say -1. So I'm going to ask you to correct that, so it should say a -1 here. So the first equation we're working with here is 3y minus 2x is equal to -1. Our second equation is 5y plus 2x equals 25. Now, if we were going to use the substitution method, we would have to solve for y or x in one of these equations. But no matter which variable we use, it's not going to be pleasant, because if we divide everything by 3 to solve for y, we're going to end up with 2/3. Or if we divide everything by 2, we're going to end up with 1.5. It's just not quite that simple. So what we're going to do is the elimination method. Step 1 says, write each equation in the same form. So what that means is that here, ax plus by equals c is one possibility. In other words, you want to line up the variables. That's what you have to worry about first. So I look at my equations and I see here the y here and y here, so the y's are lined up. X and x is next. The equal sign is lined up, and then the numbers are on the right side. So it doesn't matter how they're lined up, but they need to be lined up in exactly the same order. So in this case, that's done, so I don't have to worry about rearranging anything. Okay. Now, the next step, it says multiply one or both equations by a number to get coefficients that are opposites. Now remember, opposites are a positive and a negative pair. So +2 and -2 are opposites. +7 and -7 are opposites. So I look here to see if my coefficients are opposites. Well, 3 and 5 are not opposites. -2 and +2 are opposites. So I'm all set with that. I have coefficients that are opposites. So I'm going to write down my equations right here. I have 3y minus 2x equals -1. And then my second equation is 5y plus 2x equals 25. So all my variables are lined up, and my x's are opposites, which is exactly what I want. The next step, step 3, says add the equations together. So here, if I add these two equations together, I see that when I line them up and I add them together, I'm going to get 3y plus 5y is going to be 8y. I'm going to combine like terms. -2y and -2x and +2x equals 0. These actually cancel out, which is what I wanted. That's why I wanted them to be opposites. And then -1 plus 25 is 24. So now I added the equations together, and one of the variables eliminated. That's why it's called the elimination method. And so finally, I have one equation with just y. So step 4, solve the new equation. Well, that we know how to do. 8y equals 24. I'm going to divide both sides by 8, and it's pretty easy. Y equals 3. Now you know that when we have y, we're not quite done. We have to find your x variable. So you're going to substitute that into either equation. So I'm going to go up top, and I'm going to choose either equation. It doesn't really matter. I'm just going to use the first one just because it happens to be the first one that's there. So I'm going to substitute in y equals 3 into my equation. So I'm going to write 3 times 3 minus 2x equals negative 1, just like we've done every other time. And now I solve. 3 times 3 is 9, minus 2x is equal to negative 1. I subtract 9 from both sides, and I get negative 2x is equal to negative 10. Divide by negative 2, and x is equal to 5. Now I have my solution. X is equal to 5, y is equal to 3. And then, as you know, you can write it as a coordinate pair. 5, comma, 3. So this method is different because what we do is we add the equations together to eliminate one of the variables, but the rest of it is exactly the same. You solve for one of the variables, then you substitute in to get the other one. The check is also done in exactly the same way as we've done all the other checks. You're going to write down your equation, 3y minus 2x equals negative 1, and then you're going to substitute in. Y is 3, so 3 times 3 minus 2 times, I think x is supposed to be 5, so I'm going to test that out, equals, and here's my question mark, negative 1, because I'm going to see if this is true. 9 minus 10. 9 minus 10 is negative 1, so I see negative 1 does equal negative 1, so that worked out nicely. And now I test the other equation. 5y plus 2x equals 25. 5 times y, so 5 times 3 plus 2 times x is supposed to be 5 equals, I hope, question mark, 25. So now I evaluate this. 15 plus 10. 15 plus 10 is 25, so this one also worked. Okay, so to review, you want to line up your variables so everything is in the same order. Hopefully one of the variables will be opposite, so they cancel. You add the equations together and solve. So let's try the first example on the next page. So example number 1, you have 2x plus 3y equals 11, 2x minus 5y equals 3. So step 1 says to line up the variables. Well, I have x over x lined up, the y's are lined up, the equal sign is lined up, and the numbers are lined up, so that's all set. Everything's fine. Step 2, I want one of the sets of coefficients to be opposites. Well, the y coefficient is 3 and negative 5. Those are certainly not opposites. The x coefficients, I have 2 and 2, so I'm close, but I need them to be opposites. So what I'm going to do is I'm going to multiply the second equation by negative 1 so that they can be opposite. Let me erase that one. It looked like a negative sign. So I'm going to multiply the second equation by negative 1. So by doing that, this will become negative 2, and then my coefficients will be opposite. Now remember, you have to do it to everything. So when I do that, I'm going to get negative 2x, a negative times a negative is positive, plus 5y equals, a negative 1 times 3 is going to be negative 3. I'm going to copy over the other equation above it just as it was, so I can line them up. Now my x's are opposite. My x coefficients are opposites. So I'm going to add these two equations together. And then when I do that, I get 2x minus 2x is 0. 3y plus 5y is 8y equals 11 minus 3 is 8. So now I just have y. And I can finish solving. I divide by 8, and I get y equals 1. Now that I have y equals 1, I have to figure out x. So I can just substitute y in my equation right here. It doesn't matter which equation. 2x plus 3 times y is 1, equals 11. So 2x plus 3 times 1 is 3 equals 11. I subtract 3 from both sides. I get 2x equals 8. Divide by 2, x equals 4. So there's my solution, 4, 1. That's the point where these two lines would intersect. So again, step 1, I make sure that the variables are lined up. In this case, I had to multiply the second equation by -1 to get them to be opposites, and then I added them together. So please try examples 2 through 4. When you get to example number 4, it's going to ask you to do a check, which you know how to do. If you have any questions, please make a note of them and bring them to class. Thank you very much.